Okay, so today we're going to be doing inverse functions. So, the inverse of a relation consisting of order pairs x, y is the set of all order pairs y, x. One way to look at it when you're trying to actually find the inverse is simply just switch x and y. So for the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. Since x and y is switched, so does domain and range. And for the function f of x, the inverse is usually represented as f with a -1 almost as an exponent. So but it's read as f inverse. So if this is a function, that does not mean a negative exponent, it means the inverse. So keep that in mind as we go through today. There we go. Some common examples of inverses. Let's see. Addition, the inverse of addition is subtraction. Inverse of multiplication is division. Inverse of squaring something is square rooting something. So those are some simple inverses that you have already come across in math. So if we look at example 1 here, we're supposed to find the inverse of each and then determine if the inverse is a function or not. So for A, the inverse, notice that we have a bunch of ordered pairs, and the ordered pairs are in squiggly brackets. So that is just a list of all the ordered pairs in the set. That's what the squiggly brackets are telling us. So, as I go through, to find the inverse, you simply switch x and y. So 2, 1, 4, 2, 6, 3, and 8, 4. Just put them back in squiggly brackets there. So if you look, the inverse is indeed a function. Now the x values are repeating for number A. Number B. So again, switch x and y to find the inverse. So 5, 1, 6, 1, 6, 3, and 9, 4. I'm putting them in squiggly brackets to tell me it's a list of ordered pairs here. You can see that the 6 repeats, so this one's not a function. I should probably write function up here. So there we go. So that's it for example 1. Example 2, find the inverse of f of x equals 3x minus 2. So before I do anything, I'm just going to rewrite this. A lot of the times f of x confuses people. Just remember f of x is the same thing as y. So what we really have is y is equal to 3x minus 2. Well, how do you find the inverse? Switch x and y. So x equals 3 times y minus 2. Now it's a simple matter of solving the equation for y. So I'm going to add 2 on both sides. So x plus 2. Remember, they're not like terms, so we can't combine anything. And then we will divide both sides by 3. Divide the whole thing here by 3. Giving us y is equal to x plus 2 all over 3. You may also see the answer written like this. F inverse of x is equal to x plus 2 over 3. Or you can also see the answer with it broken up into 2 separate fractions. There's a lot of ways to represent the final answer for this, especially with the fraction there. So you can also write it as f inverse of x equals x over 3 plus 2 over 3. And you can write the same way, just with a y instead of the f inverse. So there's a bunch of ways to write the final answer. All are acceptable. So just remember, you write it as an equation. So we'll go over the extra example here. So for the extra example, as we go through it, again, this is y equals. So it's really y equals 2 over 3 x plus 5. First step in finding the inverse is to switch x and y, so we'll have x equals 2 over 3 y plus 5. Now we'll just start solving for y. So subtract 5, subtract 5. So we get x minus 5 equals 2/3 y. Now, one way of canceling out the 2/3 is dividing by 2/3, but writing x minus 5 over 2/3 is not pretty. Therefore, I choose to use the other method, which the basic way of canceling out a fraction through multiplication is to multiply by the reciprocal, which is 3 over 2. Multiply by the fraction, just flipped. The 3's would cancel out, and the 2's would cancel out. What you do to one side, you have to do to the other. So 3 over 2 on the left side as well. So we have that y would equal 3 over 2x minus 5. You could also rewrite it with the f inverse notation. You can also distribute out the 3 halves. There's, again, a few different ways you can write the final answer, but this is acceptable. If you want to distribute the 3 halves, you can. Next one, a note I just made. You'll see this on the classwork assignment. If you would like to give the ones with the square roots and the squarings a try, that's awesome. We will cover those specifically later in the year. So just remember that squaring and square root are opposites of each other. So, okay, next. A function's inverse is only a function if it is 1-to-1. So this is the 1-to-1 line test here, or the horizontal line test. So running a horizontal line test will actually tell you whether the graph of the inverse will be a function. If it hits more than 1 point, then the inverse will not be a function. So in example 3, we're determining if the graphs of the functions below have inverses that are functions. Functions that are inverses. Yeah, read that backwards. And then we're supposed to sketch the inverses. So if you look, this one hits it twice, so the inverse is not a function. We're still going to sketch the inverse anyways. So I'm going to zoom in so that I can do this. If I look at order pairs, I'm going to just use these 3 order pairs. 0, 0. Actually, I'm going to start with this one. Negative 1, 1. Negative 1, 1. When you flip the x and y, it becomes 1, negative 1. It moves down here. The next order pair is 0, 0. When you flip x and y, it stays 0, 0. So it will stay where it is. And this next one, 1, 1, when you flip x and y, it will become 1, 1. What we see is the graph has to go from this first dot through here, like so. That means when we flip it, it's going to go through the dots in the same order. So we'll go from the green dot through the red dot, then to the yellow dot. We should get that U shape going out. So you can see the graph of the inverse. It's now a sideways U. We go to the next one. If you look at this, no matter how many horizontal lines I draw, the inverse, it only hits once. So the inverse is a function. So E is fun. Erase these vertical lines I drew, and of course it's not erasing by a lot. I'm gonna try to erase it a little faster. Whee! Okay. Now again, since this is a straight line, I really only need 2 points to help me with the graphing. So I'm just gonna pick some order pairs I can see. This one here will work, and this one here. So the first order pair that I chose is the order pair, what is that, 0, 1. So when I flip the x and y, it will become 1, 0. So right there. The second order pair I chose was -2, -3. When I switch x and y, it becomes -3, -2. So it moves right there. It's going to be a straight line going through those 2 points. And there we go. Next, we have the square root graph. So you can see no matter how many horizontal lines I draw, I will only hit the graph once. Therefore, the inverse is a function. Okay, from here, I'm going to pick 3 points. Pick this one here, this one here, this one here. I'm using 3 points just to help me get the shape a little bit better. So the first point I chose right here, the order pair is 0, 0. Well, when you flip the 0, 0, it stays 0, 0. Second order pair I chose was right here. It's 1, 1. When you flip 1, 1, it stays 1, 1. So that's why I chose 3 points, because those two didn't move, and it's very hard to tell what the graph is going to be doing. This third one has an order pair of 4, 2. When you flip the x and y, it's going to be 2, 4. So the graph will have the same shape, just flipped. So that'll be the graph of the inverse there. If you look at all these graphs, they're actually reflected across a specific line. They're reflected across the line y equals x. The inverse and the original are reflected across the line y equals x. Same thing here, reflected across the line y equals x. Same thing here, reflected across the line y equals x. And that brings us to the last thing for today's note. So, the identity function is defined as I of x is just equal to x. When two things cancel out, they form the identity. So, positive 5 plus negative 5 cancels out, forms the identity of addition, which is 0. 5 times 1/5 cancels out, forms the identity of multiplication, which is 1. Well, when it comes to doing function composition, or dealing with functions, the identity is the function x. That's also why the graphs tend to flip across x if they are inverses. So in order for something to show that something is an inverse, you have to show that two things are true. First, f of g equals x, and g of f equals x. That composition we did the other day. So, since it says, for example, 4, we're supposed to use function composition to verify, that tells you that these two are already inverses of one another. We're just going to show that they are inverses of one another. So, what I'm going to do is I'm going to first find f of g. Then I'll go back and find g of f. And for some reason I wrote it in 2 different ways, so I'm going to go back and erase that. Okay. G of f. Okay, I'm going to focus on f of g first. So to set f of g up, I go through the outside function, which is, rewriting this. F of g means f of g of x. So like we did the other day, go through the outside function, which is f, and put parentheses where you see x. So it's 7x minus 2, so 7 parentheses minus 2. On the inside goes g of x, so that's 1/7 x plus 2/7. Now we just have to simplify. 7 times 1/7 is 1x. And 7 times 2/7, well, 7 times the 2 is 14, divided by 7 is 2. Minus 2 comes down. Combine like terms, these cancel out, becomes 0. So I'm left with 1x, which is just x. Now I do want to state, verify means you're supposed to show it, which means you must have steps. You must write every time you do something. Rewrite it. Even though it seems pointless, rewrite it. Rewrite. Okay, going to the other side. So one side we verified. Now we have to verify the other side. G of f means g of f of x, which means we'll go through the outside function, which is g, so it's 1 over 7, parentheses, plus 2 over 7. Going through, the inside is f of x, which is 7x minus 2. I'm going to remind you that when you multiply fractions, you multiply the top numbers and you multiply the bottom numbers. So, when you do 1/7 times 7 over 1, 1 times 7 is 7, 7 times 1 is 7, so you get 7 over 7, which is just 1x. 1/7 times 2 over 1, well, 1 times the 2 is 2, 7 times 1 is 7, so 2/7. Your calculator can help you if you struggle with the fractions. I'm going to bring down my 2/7 here. I'll combine like terms next. In order to add and subtract fractions, they need a common denominator. Well, they already have one. So I'm just going to add the numbers on top. -2, +2 cancels out, leaving you with just 1x or x. So we showed that both sides are equal to x, therefore we are done.